So a composition is taking a function and using it as an input into a function. So for example, this says g of f of x. Now notice there's two different notations. Okay, I tend to stick with this notation, okay, instead of using this little open circle, but it is important for you to know both of them just in case you saw them somewhere, like on an SAT. I think SATs like to use that one. So I have some examples to work with. So our first example, let's let f of x be x minus 2 and g of x be x squared. So let's figure out what g of f of x would be. So remember, f of x is a function. So really we're saying input x minus 2 into the g of x function. So notice I just replaced f of x with x minus 2. So now g of x minus 2, okay, notice our g of x function is x squared. So it says replace x with x minus 2. So there is the x being replaced with x minus 2, and it's still being squared. So that's our new function. And if I do it in the other direction, notice if I could also do f of g of x. Let's see what happens here. Do we get the same answer? So we're going to substitute the x squared for g of x. So I'll write f of x squared, and that would get you x squared minus 2. So notice that they're not the same function. That means that a composition doesn't have a commutative property, right? So I can't switch the order and still get the same answer. Let's try something different. Let's add in the function, how about, let's add in a radical. So h of x is the square root of x plus 3. Okay, now let's try g of h of, let's do a number this time, of 1. So let's start with the input. In this case, the input is h of 1. Let's actually figure out what h of 1 is. Let's evaluate h of 1. So that means I'm substituting 1 in for x in the h of x equation. Okay, so that's the square root of 1 plus 3. That's the square root of 4, which is 2. So really, this is saying, what is g of 2? G of 2, let's just substitute 2 into x squared, and we'd get 4. Let's try a different value this time. Let's do g of h of, let's try a negative number, like negative 4. Okay. Now remember, we want to work with this input first. What is h of negative 4? Well, that's the square root of negative 4 plus 3, which is the square root of negative 1. The square root of negative 1 is I, but that's an issue because when we have these functions, we like to say that the domain is just of real numbers, so like negative infinity to infinity. That means that I isn't allowed to be an answer in this case. So I'm not allowed to do that, which means I'm not allowed to do this either. I would say that this is undefined. Let's take a look at what g of h of x would be. Because obviously something weird is happening, right? Because we're not allowed to substitute negative 4 in for x. That makes me think the domain is restricted on this one. So let's try it. So this would be g of, what's h of x? That's the square root of x plus 3. Okay, so that means I'm substituting the square root of x plus 3 into the x in x squared over here. So we would get the square root of x plus 3 all squared, which gets us x plus 3. Okay, so let's really think about this. X plus 3 is a line which typically has a domain of negative infinity to infinity. but we just realized that -4 can't be in this domain. So let's go back to the original functions here and think about it this way. Let me change colors. It's getting a little crowded on the screen. Notice that the first function right here that we're dealing with is the h of x. That has a domain of, what is this, -3 to infinity. Right? Because if you substitute -3, you'd get the square root of 0, which is 0. And then anything above that, you'd have a positive number inside, which you could take the square root of. So because the domain is already being restricted, that seems to be causing issues. So this result is a line, but I think it's more like a ray if its domain is restricted. So I would say its domain is -3 to infinity. Let me just fill this in. So this would be g of h of x would be x plus 3, but with a restricted domain. Think about that. You couldn't just say that x plus 3 is the answer, because if you just wrote that down, I would assume, oh, it's the whole line. That domain, I didn't ask for the domain, but it's a part of that answer now. Let's do some other examples. Oh, you know what? Let's do this. Let's do it in the other direction. Let's do h of g of x. So that would be h of x squared. That would be the square root of x squared plus 3. Okay, so let's think about this. For our inputs for g of x, we can substitute anything in for x squared, right? Anything can get squared, and positive numbers will always be outputs for that one. And then that means that we'll always have a positive number to put in here as an output. Yeah, I think this is good, right? Because x squared is always going to be positive, plus 3 will always keep that number positive, and we can square root them. So this doesn't have this restricted domain. This is good just the way it is. So see, we didn't need to worry about that. So there is, like, it's kind of weird, and I know it's unfortunate, but I don't think there's any rule to memorize. I think you have to just think your way through this one. It's not like, oh, this domain's restricted, so that's going to be the answer. Because we were dealing with the same functions here, and there was no restriction. Let me try one more set of examples. Let's try f of x is 1 over x, and g of x is, let's stick with the x squared. Okay, so if I do f of g of x, that would mean f of x squared, which would mean 1 over x squared. Okay, let's look at the resulting function. 1 over x squared, we know x can't be 0, right? That's the only restriction that's obvious. Was there any other restriction to begin with? Well, in the very beginning, let's see, x squared's the first input. Anything can go in for x squared. In f of x, you can only put in, let's say, oh, actually I should go backwards. The only thing you can't plug in would be 0. So I think that looks good. I don't see a restricted domain on that one. Let's try it this way. G of f of x. That would mean g of 1 over x. That would be 1 over x squared, which is 1 over x squared. So again, that's the same function as an output. So I don't think we have any issues here either. I have one more that we could try. How about f of x is 1 over x plus 1, and g of x is x squared. Let's try f of g of x. Okay, so that would be f of x squared, which would be 1 over x squared plus 1. Alright, look at the resulting function, x squared plus 1. X squared will always be a positive number. We're always adding 1 to it, so the denominator can never equal 0. I don't see any restrictions on the resulting function. In the g of x for the inputs, no restrictions here, so anything can get substituted in. Positive numbers, right, and 0 will be the results of this. They will then get substituted into this value. The only thing that would make this an issue is if x was allowed to be -1, so that has a restriction. This can never be -1 anyway. Let me talk you through this again, and then I think we'll finish this video so you can practice on your own. But here's g of x. X can be anything because anything can be squared, but the result of g of x can only be 0 or positive. Well, if the result of this can only be 0 or positive, that's the only stuff that's going to be plugged in to f of x. So that's not going to make a difference here, right? -1 was the only issue. So really, there's no restrictions on this one either. So again, it's showing you that it doesn't matter necessarily what the domain of f of x or g of x is. The composition of the two functions might result in a completely different domain. It might take on the domain of one of these functions. It might have no restrictions at all, even if the f of x and g of x function had restrictions. So hopefully in class you'll get to practice more of these.